Welcome to the Tech Trends Podcast, where we discuss the latest manufacturing, technology, research, and news. Today's episode is sponsored by Modern Machine Shop Made in the USA podcast. I'm Ramia Lloyd, Associate Content Manager and Tech Trends Podcast producer.
Nice.
And I'm here with...
I'm Elissa Davis. I'm the Digital Community Specialist for AMT.
Stephen Lamarca, Senior Technology Analyst.
Benjamin Moses, Senior Director of Technology. Guys, that was the driest intro ever. But
We're old.
Yeah, that was really just Ben's way of
We're
flexing
seniors.
on
a
us.
lot of seniors here. I want to jump into some testbed topics. I know because we've been making quite a few advancements this past couple of months. Steve, fill us in on hardware updates.
So we made huge advancements in like the last 2 months towards building literally a digital twin of our test bed. And speaking of testing, that has tested our computers that we currently have over at the test bed, which is a hand-me-down. It's a decommissioned AMT development computer, which is a strong computer, but we've tested its limits, and we found them very quickly.
Yep.
And we learned pretty quickly that we need a proper, dedicated computer for doing digital twin simulation, modeling, and AI work. And when Sharab looked at in the NVIDIA Omniverse Isaac Sim system requirements, it showed, it laid out in a nice little table minimum requirements, recommended requirements, and ideal requirements.
Right.
And
I like those tables because they're common across everywhere.
yeah, across
video games.
Like video games tell you, well, like console games, PC games tell you, like you need this to run this game.
Right.
You probably should have this, but if you really want the best experience, you want this. It's amazing how software just does that. It's very nice.
I think you're going to hit on one of the points that I hit on about that table too.
I don't know what point you're talking about, but we'll probably get there. The recommended, meaning like this is what you should have if you really want to get the best experience with our software possible for Isaac Sim.
Yep.
We spec'd out some computers and went to IT and talked to them, and we're like, okay, we need a computer from our supplier, which is Dell, that has all of this hardware and capability. And they came back to us and was like, this is going to be a $9,000 computer.
So to be fair, that's the recommended setting.
Recommended. Then we looked at ideal.
Okay, you look at ideal.
Then we looked at recommended, which is in the middle. Sorry, I messed that up. Ideal is like best. Mid-tier, recommended, and then minimum, which we already have. We have minimum, and it's not enough. So we're looking at recommended. We looked at the recommended PC from Dell, and they were like $5,500, and it's like it's still a heartache.
That's the funny part. That's the funny part about the table that I see across the board everywhere. It's like the basic is like $1,000, but even on the gaming side, the high end is literally like $5,000 more.
Yeah.
So the total cost it's outrageous. The spread on that table is outrageous.
Which is funny because like for gaming, like as an individual gamer with a limited pocketbook, like $5,000. That's a lot of money for something that's going to be out of date in 4 years.
It's expensive to be a nerd.
It is so expensive to be a nerd.
That's the realest advice ever.
But for computational power in a corporate structure and in something like manufacturing, modeling, AI work, digital twin, chump change. That is chump change for them. But the test bed runs on a limited $10,000 annual budget. So we can't be dropping 90% of that on a computer that we're going to use once a week.
Yeah.
Understandable.
The computer's designed, like those system requirements, that software is used or is to be used in a professional and industrial setting 24/7. That thing doesn't get turned off and it doesn't have downtime. It's constantly running. We realize we don't need that, number one. Number two, this is a corporate price. Like, they know this is a corporate tool. Dell knows this is a corporate tool. They know that, like, if you want to play with the big dogs, and if you are a big dog, a 9K computer is, you can do that if you need it. It's not hard.
Well, to be fair, it's coming pre-built, right? It's
That's a
coming with
pre-built as
warranty
well.
and all their services. right?
Not just a warranty. Warranty is like you can go on Amazon and buy something.
Right.
We could have got a warranty for the GPU that we bought for the spoiler alert PC we're building. But it's not the same as what Dell would offer, which is a 3 years service plan. If something goes wrong, if something dies on it, it's no questions asked. You send it back to them, or they come and get it, or diagnose it. And if they determine, something crapped out on our end, we're replacing it. That's good for 3 years. That's worth a lot. But when with our limited budget and with the way nerds can be very frugal using a website like PCPartPicker.com, we were able to build a computer, spec out a computer that is almost all of the components are in the recommended tier.
Mm-hmm.
And the GPU is in between all of the components are in ideal. The GPU we bought is between recommended and ideal because the GPU is
That's the biggest cost, actually.
the computer without the GPU that we built is insanely powerful, and it's $1,500
Right.
without the GPU. After buying the GPU, $3,600. That's $2,100 for something that just does a bunch of really dumb, easy calculations a lot at once, really fast.
I think that's the biggest takeaway because I've been thinking about the test bed in general and the ability to get to because all of our equipment is accessible, right?
Yeah.
It's low footprint, low cost for the most part based on our budget or year-over-year spending. But getting into the workstation environment, especially on the test bed environment, being able to just I wouldn't say hack your way through it, but build your own to see is this investment worthwhile to say I need to go to Dell because to your point, right? We need to see if it's valuable.
Yeah.
And what type of scenarios you can run, and then get into a production environment. So, I mean,
if
it's a
you think-
really useful experiment.
And I just have to throw in a slight towards Apple here. And if you think that the Dell price tag is high, that's cute because that's a third of what you would get for the equivalent computer from Apple. Because Apple would take our build, a $3,600 build,
Right.
easily add a zero to it. That would be a $36,000 computer from Apple.
Add another $1,000 if you want wheels on top of your workstation.
But
So, and you do get into some really interesting points that we'll hit on later is about computing, the need for computing, because we're talking about cooling and energy usage and stuff like that.
Right.
There's a really big difference on, because that's a workstation GPU basically, right? So
it's not workstation GPU, so it's not for gaming.
Right.
It could game, but it's not designed for that. And that's an interesting topic because I don't think a lot of gamers can wrap their head around that. It's twice the price of a gaming GPU, and it doesn't game as well.
Right.
That doesn't make sense to me. Well, it's not for doing that. It's for a different reason. It's for thermals. It's for stability. The industrial workstation GPU is running 24/7. It doesn't stop. Your gaming GPU is more powerful, but it's only gaming for 6 hours on end until your eyes bleed.
right.
And then you turn it off and go to bed.
Yeah.
My brother had a crisis this week. So, last week my parents were in Hawaii, and so my brother was dog sitting for them. He also cat sat for me while I was at Empty Forecast. So
Nice.
props to my brother for driving from Ashburn to Fairfax to do that for me. But he has a gaming headset that he uses because he's built his own computer. He has a computer at school that he built, that he uses that for gaming. And he texted our family group chat yesterday, and he goes, "I forgot my headphones at our parents' house." And
He's distraught.
yeah, and he lives on
Stressed.
campus in the dorms at Mason, and so he was like, okay, I don't know when, but he doesn't have a car, so he's like, I don't know when I'm gonna get to our parents' house until probably at least this weekend.
Right.
And so he was like, okay, I guess I'll just have to get an adapter, a Bluetooth, like an aux cord
Yep.
to plug in, and I was like, well, if you need headphones, I have a ton of Bluetooth headphones. You can just borrow a pair of my earbuds. He goes, no, my computer is not Bluetooth compatible. I have to have the aux cord. And I was like,
Man.
that sounds for the computer that you built, it doesn't have the Bluetooth compatibility. That's wild to me. So, but he was just like, it's fine. I'll just see. He's gonna see if his boyfriend can take him to my parents' house today to get his headphones.
I don't think you're giving your brother enough credit. He was saving you from a mansplanation of basically that, like, any real gamer does not connect through Bluetooth. It's not stable enough.
No, I know.
You want to hardwire that cable. And he saved you from that explanation, to which I'm here to fulfill.
My brother has 4 sisters. He would never try and mansplain anything to me.
God
He knows
bless
better
him.
than
What a
that.
gem.
But yeah, so that just made me think of that because I was like, oh, he built this whole computer, and then it was like, oh, I have like 4 pairs of Bluetooth headphones. Do you want to borrow one? No, it doesn't work. And I was like, what? So, because growing up in the age of plug-in headphones, you're just like, ooh, these Bluetooth ones are so cool, but gamers hardwire into the set, so, or the computer, whatever it's called.
I host a podcast party. You can see all the cables I have coming out of a machine. There's nothing wireless in my setup at home. So mansplaining and other lingo terms that we should die. Steve, you hit out some corporate terms.
Corporate lingo that needs to die. And I tried to pick Elissa's brain earlier about things that need to die on LinkedIn, because that's where this is why I'm bringing it back up. Immediately after, like, maybe not Saturday after IMTS, but Sunday after IMTS, my LinkedIn feed was flooded with literally the same 2 phrases for the entire next 2 weeks.
Was it GTK?
And that's a wrap.
Oh.
This is one for the books. You don't have a book. You don't write a book. There's no book. Stop saying this is one for the books. What books? Everything's digital now.
This is one for the Kindle?
That's a wrap. That's a wrap. What does that even mean? Where does that? What is the etymology of the phrase? That's a wrap. What's being wrapped up?
Why are you so upset about this?
Because
I don't understand.
I saw it so much. It was the only thing on my LinkedIn. It was the only things that and that's a wrap. From literally all of the people in the world. It's like, you can't have an original thought. You just came from IMTS. Like, and you're using literally the same thing everybody else is saying?
So, as the person who runs our social media, I'm going to tread lightly here. But on a platform like LinkedIn...
I need aspirin.
On a platform like LinkedIn, it is very group thought-ish, where like...
Hive mind?
Yeah. So like if someone sees it, someone else is going to post that. Whether they even realize they're doing it or not. Yeah, they're gonna post that, right? And sometimes, like, there are times when I'm sitting there staring at the computer, like, what is a good phrase? And I'll be like, that's a wrap. I'm like, no, we use that too much. But like, I have to think about us as the brand, not just like myself. If it was just myself, I'd probably post that's a wrap, to be honest with you, because I'd just be like, okay, because the that's a wrap leads into like the recap, right? So I have to be careful because I run our social media and I don't want people to stop tagging us and stuff.
So you run social media, but like you're not an influencer.
No.
I saw it from a lot of the influencers
of course.
too.
Yeah.
You're it's your job to have an original thought.
I have 2 notes. As a person who probably put that's a wrap in her LinkedIn post, in my case, it counts because that's a wrap originated in the film industry, and I worked in media.
That's true.
That's all I did for IMTS. It's like a wrap. Like you're wrapping up the end of the filming progress. Like the filming
but
is
we
wrapped.
still need to break down the etymology of wrapping up. What is literally being wrapped up?
The carpet.
That's you're wrapping up the carpet. You're wrapping up your filming.
Is that it?
I don't know.
Oh.
No, it literally
so
means like you're.
believable.
I think of like red carpet, like you're wrapping it up.
It's
right?
like it's from film.
Rolling
You're
it up.
wrapped up. So you when the film ends and like you're finished filming, you have a wrap party. Like you're just wrapping it all up. That's
Thank
the
you.
end of it. So that's my explanation for it and why it fits.
Thank you.
Are you less angry now?
Yeah. Can we still kill it?
We can, yeah. But I'm telling you, that's why I use it.
I really like the escalation of a term. That's fair. I mean, it's overpopularized. But it could have taken 2 seconds for you to answer this, Steve, before we got here. You could have looked up the etymology of that's a wrap.
But wasn't this better for the camera?
Clankers.
And that's a wrap.
Blinkers.
I mean, they do say like the one for the books. That is one that I do kind of like. I use that, and that's partially because like
But you're actually writing a book. I feel like you're allowed to say that.
But
what
it's
if you journal? Does that count?
What,
Yeah.
Because I talked about IMTS a lot in my journal. So
the
does that count?
next level
You're
is
allowed. What did you look at?
Thanks.
if they start putting the acronym or the acronym for that's one for the books, that would throw me over the edge.
TO.
FTB.
TV. That sounds better.
TOFTB.
Tough.
So, Steve, you also mentioned something about words we should stop using about robots.
Oh, a word that we don't have to stop using yet because it's just become a bad word, but it's not cancelable yet, is the derogatory term for robots.
Tell me.
I'm not going to say it.
Are you waiting for me to say it?
Somebody else say it.
Clankers?
Yeah. Send them back to the factory.
Why would you make Ben say that?
How did that come up? Why did you run across that?
It's something. I saw it on social media.
Okay.
Send him back to the factory.
So the idea. So I do have an interesting concept I want to talk to you guys about humanizing robots in general, or humanizing technology in
Yes.
general. So giving a tool a human name. I don't think that's useful in the future. How do you guys feel about that? I think we should just call it.
It's amazing that you're bringing that up now because my house, we just watched the first Ant-Man movie.
Sure.
Oh my god.
And Michael Douglas's character, I forget the name, Professor Pym or something,
Yeah.
something
Hank-
like that.
Hank.
Hank Pym. Like he's controlling the ants. He can communicate with the ants. And he's like, they don't have names. They have numbers. Do you even realize how many ants there are? They can't
Right.
all have a name.
Yeah.
They have numbers. It was like,
Anthony
this is
says
very
different.
insightful. The Ant-Man,
But
that was an insightful movie. Robots shouldn't have names.
the counterpoint was the Ant-Man that I forgot his name, Paul Rudd's character, does start naming the characters.
Anthony.
Yeah.
His name is Anthony, and he's amazing.
But to your point, I mean, if you look at, they're like insects are kind of like in between of, machinery versus, something that could be anthropomorphized. But when you look at a piece of
High-ranking robots are allowed to have names.
high ranking,
Yeah.
So-
Anthony was just the one ant that they constantly went back to.
So my question is then, at IMTS we had Apollo from Appatronics. His name was Apollo.
Was that robot's name Apollo, or was that the model?
It's a great question. I don't know.
Because
think,
I would like to know Apollo's serial number, and then I'm calling him by the last 4 digits. If it's a him, they, them.
while we're talking about robots, I do want to talk about Tesla. They released a bunch of stuff recently. So we'll further upstream. Mark brought this up about Tesla obviously working with humanoid robots. To your point, we saw Apollo at IMTS, but there's a big influence and big resurgence of humanoid robots. And I feel like there's a parallel of lesson learned from AMRs and their influence to where we are with humanoid robots, where BMW is experimenting with them in their factory.
Yeah.
There's still a lot of experimentation, like pre-innovation space, still in the hype cycle, I think. What is your guys' hot takes on humanoid robots?
So first, I just want to say I saw something on Twitter where it literally compared shots from iRobot to the things that Tesla released.
Sure.
And they're exactly the same.
Sure.
And I just feel like that's important to note and just shows further that Elon Musk is trying to destroy this world. Anyway,
It needs a reason to get to Mars.
I
It
love your
destroys this.
long-standing beef with Elon Musk. I support it.
I've never liked him.
I so support it.
Even when people were like, "Ooh, he's like, changing the world." I'm like,
No.
but he could change it for the better, and he's not. Like, he has the money to do it.
All right, back to humanoid
Anyway,
robots.
man.
Humanoid robots. I mean, I don't know. I thought Apollo was just really cool at
Yeah,
IMTS.
it
Like,
was.
and how they're teaching him, through modeling how to do everything. So he has like that kind of human aspect, but it's like not scary human.
Sure.
But he has a very non-threatening face, where Elon's robots have no face,
Okay.
and that
Did
makes
Apollo
me,
not have a face?
he had a face.
It's subtle. It's very subtle.
Yes.
Because they had the cameras built in. So
I don't
you
think he had a
stereo
mouth.
vision.
He had like
I don't know.
he had like
But
eyes.
They were built. I wouldn't say they were built in. They were modular cameras because that was an Intel RealSense up front, and there was also an Intel RealSense
Sure.
camera in the back of his head. So it's like this robot has eyes in the back of his head. I don't trust this robot. Literally has eyes in the back of his head. That's not true. Apollo's fine. It's a piece of equipment. But my favorite comment on Apollo was Asa. Asa Gurney was like, "Yo, Apollo doesn't skip leg day. You seen that guy in his quad?" It was like, excellent, astute observation.
Because I was under the table, so it's a good observation.
Just peeking under the table on Paul's legs.
I
So-
also want to go back really quick to the ants and Ant-Man. The other one's name is Antonio Banderas.
I love that.
I
So
totally
there's
missed
two,
that one.
and they
That
have
was good.
names.
So many
Thank
good
you.
puns. Paul Rudd's good for puns.
Anything Marvel, I got you. I was like, I know they have names.
The last thing
Antonio.
I want to hit on with Tesla is they just released the robo-taxis, which actually is funny because there's like 30 different names for the robo-taxi that they aren't official yet. But
Once again, looks just like iRobot.
iRobot just picks you up and carries you around. But what they're releasing is a car that has no drivability. It completely drives itself. So
I love that.
It's literally, you order it, it pulls up. There's 2 seats in this one that they're unveiled. No steering wheel, no pedals. There's no buttons for a door. The doors open by themselves, and you have to use the touchscreen to open the doors. And it's supposedly priced pretty low, but as people that travel quite a bit, I want you to get your hot take about ordering it is a driverless car, because there's no ability to drive it at all. What's your confidence, as in right now, to order a driverless car?
See, I'm split on that because
Same.
one, I'm less likely to be human trafficked in a not in a driverless car.
Excellent point.
However, if someone's controlling the robo-taxi, then that's a whole other story. But I think I've just heard too many horror stories about the self-driving cars and stuff like that I would unless it was on a track, I would get nervous.
Okay.
I
Yes.
trust things on a track, like a trolley or
Yes, I need
like
it
a
to be
cable
on like
car,
a trolley track.
Yeah.
I
anything
agree.
like that. I'd be like, okay, fine. Like it's got a direction to go in, right? But if it's just like on the street,
Free roaming.
like I've seen humans who are absolutely insane drivers. I wouldn't trust a car that doesn't have a driver to
Okay.
not be insane.
I don't know. I
It's
think
kinda
that
cool
cleans
looking,
up
though.
some of the flaw of humans. Like I pass humans on the way to work every day that are supposed to be driving their car that has controls in their vehicle, and they are literally in their right hand watching YouTube. on their
Yeah, I've seen
phone.
that too.
And it's like, you know what? Can you just not have a like if you don't want to drive, you shouldn't have a car that can be driven.
Sure.
You should be driven in a car. And, you know, not everybody has the money for a chauffeur, so I think it's great. Also, once the algorithm, I'm just using that as a buzzword. I don't know if it's an algorithm or not. But once the programming is ironed out
Sure.
to where it's much safer, because there have been problems with it. Teslas, there's their autopilot mode, which they tell you shouldn't be using.
Right.
Like it's just a fun thing to have. Like you should experiment with it every now and
What's
then.
the point,
but you
Elon?
should not trust it. It's freedom. But it's been known to kill motorcyclists,
Sure.
especially on HOV lanes, because it sees cruiser motorcycles like Harleys, and it sees the 2 little taillights in the back down low by the rear wheel. The vision systems are not advanced enough to tell that is a motorcycle that's very close. It thinks it's a car very far away,
Oh.
so it speeds up and just like runs over a motorcyclist. It's happened. Like they're covering up a lot of motorcyclist deaths.
Sure.
Like that's something I'm very not cool about Tesla.
Well, they've been recalled in China like a bazillion times for their
One-
self-driving
well,
stuff.
I mean, also, do they care if people die? I don't. But like, the other thing is that I do think is cool is if the navigation in the Tesla autopilots has to be rerouted. The programming knows the capability of the vehicle. And when people were first playing with the autopilot and they had to reroute like mid driving, mid transit, the car would literally like do an e-brake turn in the middle of the road and change directions, and it was freaking out the passengers.
Right.
It's like, oh, humans have a G tolerance,
Right.
like we can't be doing J turns in the middle of traffic, regardless of how safe it may be, because nobody else is around. Not a cool thing to do. And the driver still gets pulled over. It wasn't the driver
Right.
that did it, but they're still the captain of the ship,
Yeah.
and they're the ones who are in control. I think it's great because as somebody that still likes to drive, if 70% of the cars around me are autonomous and following a guideline or following guidelines that, hey, there are traffic laws in place now that people don't follow because they're on YouTube. If the program, which can be trusted to follow the guidelines better than humans can, then think of all of the autonomous vehicles that will be on the road. Let's say it's 70% of them. Think about how many cars you can cut off, and they will put on the brakes, and you can speed away, and they won't think anything of it because the person who should be driving, who isn't driving, isn't even paying attention anyway. It would reduce the stress of your commute by so much. So I have no figures on anything.
There's two takeaways that about back to basically autonomous machines in general. We started the conversation on human robots, and obviously with Tesla's robotaxis. The key thing is and I think it gets into a lot of technology adoption issues. There's a lack of trust. There's a lot we don't know about it, and the observable influences versus what the company is pushing. Like to your point of accidents with motorcycles, that's a fairly big issue, but no one's talking about that. But the idea of we know there's flaws in the system, and there's the companies like in this scenario where they're willing to push as much as they can, learn as they're going into production, and then feed that back into the overall confidence model. It's an interesting point about the trust in the technology versus the actual use case. Right. To your point, you hit on a scenario where in the Northern Virginia area, everyone's on their phone.
Oh my God, so scary.
Deepa yells at me all the time because I give people 2 seconds at the light. If they aren't moving, I honk because I know they're texting.
Your horn is not optional equipment. It's standard equipment. You should use it.
So the problem statement of distracted humans needs to be solved with autonomous driving. That is one solution. I mean, there's other ways to solve the problem of distracted driving too, right? So back to the technology issue where we're all interested in is there's still a problem with building trust with autonomous equipment because there's a lot we don't know. There's the black box that we're unsure of, right? And that's where I think the next evolution is about with the autonomous vehicles and autonomous technologies is how do you build trust with that equipment?
If I got into a taxi and there was no one driving, I'd be really scared. Like if I got into a regular taxi and then it just started moving and no one was driving. Yeah. I'd think I was dreaming. I think I'd be like, this is my nightmare.
Like if you jumped in a vehicle and it was like was it Waymo that's retrofitting a lot of cars. Yeah. You didn't see the branding, you just jumped in, there's like no cars, and then it takes away. That would be alarming.
That'd be terrifying.
Every other Lyft, Uber, taxi that I get into has a tire pressure light, maintenance required light, or check engine light on. Like
the tire light I let go.
The drive, no. I'm not going to let that
go.
That's what killed Paul Walker.
Mine is so sensitive, though. Like none of my tires are low if my low tire light is on.
Well, that's a different problem statement.
Yeah, well, you need better sensors.
Let's move to today's sponsor, Mia.
Tune in for Modern Machine Shop's Made in the USA podcast to explore manufacturing issues faced by companies making an intentional choice to manufacture in the U.S. Featuring commentary from OEM leaders, Made in the USA blends its nearly century-long expertise with a unique audio storytelling experience to shine a spotlight on the past, present, and future of American manufacturing. Find Made in the USA on Apple Podcasts, Spotify, and all major podcast platforms. Follow Modern Machine Shop on Twitter, Facebook, and LinkedIn.
Thanks, Ramia.
Reading is hard.
I think you did a great job with that.
You did wonderful. You.
I do want to get back to our conversation about computing.
Computers.
Also, we came in pretty hot this morning to talk about computers. Yeah. But you found an article about NPUs.
NPUs. In the last week or two, I forget when I shared that. I mean, I shared it this morning, but I shared it in industry news a week or two ago. I didn't know, when I saw this video on YouTube, which was very informative, I had no idea what an NPU was. When it comes to computers, I know the two processing units, and then the other three-letter word, the PSU, power supply unit, which is not a computer. I mean, maybe there's probably a chip in there somewhere.
Wait, what's NPU stand for?
Thank you.
We'll get there.
Oh, okay.
So you got the CPU, central processing unit, which is your main CPU. That's the main brain of a computer. Mm-hmm. It's a very powerful processor. It has a limited number of cores. Well, a smaller number of cores than something like the GPU, but it does very complex calculations. It gets a very precise result, and it's flexible. It can do many different types of calculations. Then you have your GPU, your graphics processor unit, which has many cores, a whole lot of cores, and can do a bunch of very simple calculations and really only one kind of calculation. It calculates what each individual, there is a calculation or multiple calculations to be done for each pixel on your screen. And it just calculates what color that pixel needs to be, if it needs to be on or off, and how bright it needs to be. And then the new one that is being highlighted is NPU, Neural Processor Unit.
Oh.
And this, we think of like neural networks, and a lot of people go to AI right away. Like myself, I'm just going to speak for myself. I go right away to AI, LLMs. It's like, well, LLMs, like if I use ChatGPT, that's not being done on my computer. I'm connecting to a website that is connecting to somebody's massive mainframe server that's doing the LLM work for me, and then it's just spitting back through an internet connection what the result is. But the NPU, the Neural Processor Unit, which is, as of right now, is not a dedicated standalone processor in a computer. It's more common in mobile devices, even though it's making its way to desktop, laptop, workstation computers. The Neural Processor Unit is the dedicated processor cores specifically to do predictive text entries and stuff like when you take a photo on your camera, your phone's camera, and when it processes the image after it snaps a raw picture. You can have that raw picture if you want, but most phones today will add some processing to it, which is basically it's a computer doing Photoshop for you real quick, just to make sure that you're getting what you want. By taking, the target in your picture, putting it in perfect focus, and putting everything in the background that may be standing out over your target, blurs it a little bit. That's done by a neural processor unit. And the video is really cool because it's asking the question, are NPUs going to be the next computer component that a lot of people buy for their computers?
Yep.
And it goes into the current state, and the current state with a lot of powerful computers, and it focuses on Apple's computers. The NPU, in terms of the surface area, or the square area of the silicon die, how much space it takes up in the silicon die, is actually consistent across the board, regardless of which tier processor you get.
Interesting.
Like whatever Apple's equivalent of like an Intel i5, i7, or i9, the NPU area of that die, even though the die gets larger as you pay for a bigger chip, the NPU stays constant because most computers, desktop computers, are using the same amount of neural processing. But where it's the biggest, where NPUs are the biggest, are in mobile devices.
Right.
You're using the most neural processing with your photos, with your text generation, your text prediction.
That predictive text is a lifesaver when I'm texting one-handed. Like if I have stuff in one hand and I'm like trying to text with the other, that predictive text, sometimes it's way off.
Yeah.
But a lot of times I'm just like, oh yes, that's, like I type like 2 letters. And it's like, this is what you want. I'm like, yes, it's exactly what I want. Thank you.
You might be a candidate for somebody that would want to invest in a larger NPU for your next phone or computer.
And you did bring up a couple of interesting points where, like, the importance of edge computing, right? Mobile devices are the true edge computing, where
Yeah.
you're trying to figure out, should the device be computed at the point of information gathering or at the cloud, right? And that gets back into our conversation back to the computer that we're building, right? The scenario is like, should this, and that's a conversation we had about, should we do this on the server room or do we need a device locally? And for us, in our scenario, it made sense to do something locally because we still want to keep it within the concept of the test bed, and then understand, how do we scale up from here? Like, does scaling up mean 2 workstations, or does it go to a server instance where we build something in the server? Or in most cases, in the industrial case, you're paying for server time. NPUs are a very interesting example where you see the technology not quite being diverse, but being more specific and more narrow. So you have the CPU, you now have a GPU, which still powers like the screen itself, but now you're pulling calculations away from those two devices and having a separate device. And then at some point, like the next couple of years, we've seen that over and over again on other devices where it segregates because you can control that device or manufacture that piece of equipment, but then it gets combined into like a larger scenario where at some point maybe it's a bigger portion die of the CPU or it's a separate card, right?
Right.
And it gets back to how edge computing devices are made. But I think the biggest important thing that this plays the role in is spatial computing. When you start looking at the influence of AR applications, that is the core of why AR is important.
Right.
And the need for new NPUs would probably continue growing based on, the influence of spatial computing.
Yeah, I agree. I think I don't think it's going to get to a point where you're going to have, like, for example, on a desktop computer build, a dedicated card for neural processing. I think it's going to go more the way of like NVIDIA GPUs have dedicated cores specifically for ray tracing. Right. And then there's the other GPU cores that do everything else that isn't ray tracing. I think CPUs are going to go the way of the video also mentioned that, like, CPUs aren't really getting that. We've maxed out CPUs at like 16 cores. You really don't need more than 16 cores. But what we could see in the future is a 24-core CPU that has 16 cores dedicated for your flexible CPU usage, and then the rest are specifically for powerful NPU processing.
Yeah. The biggest takeaway is understanding what your workload is. That's the biggest takeaway is like, what do you need to do, especially in the work, at your home or whatever, you're just going to do whatever you're going to do. But in terms of like the workstation is reverse engineer your solution because it is getting more and more important about the hardware is driving your capability. Yeah. And we're going to see that when we build our workstations. Like we're going to hit a capability limit and we're going to realize if we need to do more, then we need to expand that capability. So I have one on automated defect recognition. It's actually back to our conversation about computing power. So this article I found from Quality Mag talks about quality or metrology for batteries. It was interesting where we're not doing too much in batteries, but the battery show just exited, was a wrap a couple of weeks ago.
There's a battery show?
There's a battery show.
There's a battery show.
It's actually really fascinating because...
Did you go?
No. Oh. A lot of our automation committee members are there because automation is a big portion of battery creation. But the battery show is interesting where it talks about the entire life cycle of battery. So from material sciences to manufacturing to end usage, the entire ecosystem of batteries. Not just... It's skewed more towards mobile batteries, of course, but... It's a fascinating place where, on the manufacturing side, a lot of our automation companies had a presence there. But in this case, they're talking about leveraging X-rays, specifically computed tomography, and machine learning and artificial intelligence to do automated defect detection. So previously, you would either physically test it at the end. So this also brings up the concept of where you can inspect the end component. Or the end device where, traditional manufacturing processes, you'd design, build, and then test. And then if you find something, a failure at test, you've scrapped all that value add. Where this one, they're looking at doing stuff early in the process where you can inject a rework cycle if you do have a failure or you do find a defect. So it's a very fascinating approach about using CT scanning and X-rays, basically non-destructive testing earlier in the process of your manufacturing. So I thought it was a very good article about the future of other applications where you have a lot of subsurface assemblies. And that's the biggest takeaway for me is like subsurface assemblies. Like, how do you know they work until you physically test it? Push that upstream to hopefully prevent errors.
I have a dumb question. Is CT scanning could it be considered optical metrology? I'm confident it's not considered, but could it be considered optical metrology?
We'll find out on next episode. I don't know. And the last takeaway they had was faster decision making. It's back to should this part move on or should it not? So I thought it was a good article.
Yeah.
Elissa,
Yeah.
I want to end on 3D printing.
Yeah. So, and I'm always good for ending on 3D printing. So, Yahoo Finance put out a list of the 15 most advanced countries in 3D printing.
That's fascinating.
Yes. And I was like, cool. And it's trustworthy because it's from Yahoo Finance. So, there we go. So in terms of how this is their methodology. So they rank the most advanced countries in 3D printing technology based on Insider Monkey scores, that's who wrote the article, is Insider Monkey. So they incorporated several weighted criteria, including startup scene in the 3D printing space and population adjusted patents and H-index for research papers published related to 3D printing and additive manufacturing.
Aside from the name, the process is pretty robust.
Yeah, yeah. So, and they're like, at Insider Monkey, we're obsessed with the stocks that the hedge funds pile into. So I guess that's also a consideration. So number 15 is Denmark.
Interesting.
Yeah, so Denmark is number 15.
Denmark does have a big importation scene because of their coastal alignment. So they bring in a bunch of stuff into Denmark and then export it back out to the rest of Europe.
Yeah, and it says they have a robust manufacturing industry with its focus on precision engineering and high-quality production, has embraced 3D printing technologies to enhance production processes, reduce costs, and improve product customization.
Nice.
Number 14 is Belgium. So you're going to notice a pattern is that a lot of these are European countries. Belgium, it can be largely attributed to their place on there can be largely attributed to the strong collaboration between universities in Belgium and their research institutions and private companies. So they're putting out their score is probably more weighted towards the research and the research papers that they're doing.
Right.
And number 13 is Sweden. It consistently ranks as the EU's most innovative country, providing fertile ground for 3D printing advancements.
My favorite country in the EU.
Which one?
Sweden.
Swedes.
A couple that they highlighted was GKN Aerospace and Siemens Industrial Turbo Machinery. So those are a couple in there. Oh, and Sandvik,
yep.
which is I think they're a member. Yeah.
Oh, yeah.
And then Spain is number 12. They host world-class research facilities dedicated to 3D printing. The HP 3D Printing and Digital Manufacturing Center of Excellence is in Barcelona.
Nice.
So it stands out as one of the largest and most advanced 3D printing research and development centers globally. It's over 150,000 square feet. So that's pretty big. 11 is Switzerland. It leads Europe in 3D printing patent applications per capita and in economic performance. Between 2001 and 2020, Swiss companies and universities filed approximately 8% of the patent applications related to 3D printing technologies in Europe. So it's driven by strong research institutions like EPFL, CSEM, and the iPrint Institute. Number 10 is Japan.
Interesting.
Wow.
Yeah, so they have a long-standing reputation of precision manufacturing and quality control. It's translated well in the 3D printing sector. A couple of companies they highlighted is Kurumioto and IHI Aerospace partnered with 3DO to enhance the adoption of AM technologies in the aerospace sector. Their researchers have made big strides in bioprinting as well.
Okay.
And then it was the team at Osaka University who successfully 3D printed Wagyu beef. So that was
delicious. Hopefully it drives the cost down.
yeah. Number 9 is Italy. It's 9th on the list and it's the most advanced country in 3D printing technology. So even though it's not number 1, they're considering it the most advanced. It has 3D printing companies like WASP, CRP Technology, which is a leader in high performance 3D printing for motorsports, and DWS Systems.
Are they 3D printing pepperonis?
That'd be really cool.
That would be fun.
Still waiting for a 3D printed pizza. I think you mentioned earlier, though, that they were WASP was 3D printing with clay.
Yes, they focus on large scale printers using local materials like clay.
Okay.
Yeah.
You mentioned something else. I'm sorry.
The motorsports, the CRP Technology,
right,
a leader
that's
in
right.
high performance 3D printing for motorsports. That's also in Italy. Number 8 is China. So China is number 8 on this list. Boosted 3D printing through national development goals and the Made in China 2025 initiative, which highlights its role in industrial transformation. 7 is Netherlands. The Netherlands 3D printing market was valued at $13.3 billion US dollars in 2023 and is projected to grow a compound annual growth rate of 20.9% from 2023 to 2030. Number 6 is actually Australia. That kind of surprised me.
Those guys are wild.
And they've got, and that's again a large part due to research that they're doing down in Australia.
I wonder how connected some of the research is with some of the defense doing.
Oh,
Because
yeah.
we were talking about how much money they're just pouring into defense the past 10 years, and it's been a lot.
Yeah. They say, so yeah, they're focused on fused deposition modeling is the most commonly used 3D printing process in Australia due to its simplicity and cost effectiveness. And prices for 3D printers continue to decrease, starting at as little as 2,000 Australian dollars for a 3D printer that you can buy. Number 5 is France.
France.
Hey,
we haven't talked about France in a while. They don't come up much in manufacturing. They're pretty high up.
Yeah.
That's interesting.
Yeah. Well, they've got, companies like Dassault Systems, Safran, and Airbus are investing heavily in AM technologies, and they're all based in France.
That's
right. Dassault is huge. Dassault and Airbus. That's the only reason they're up there.
And the French Navy has recently validated the use of Meltio's metal 3D printing technology for manufacturing and repair processes.
Meltio is huge. They came out of nowhere.
Yeah.
Number 4 is Canada.
Oh.
They invested over $20.8 million in funding in 2023 to help businesses access 3D printing technology and create jobs.
I like the fact that it sounds like they put it right to the end users as opposed to in the process.
Yeah.
So further adoption.
Number 3 is Germany. So according to Maximize Market Research, the German 3D printing medical device market alone is valued at $1.24.81 million US dollars in 2023 and is expected to grow 13.9% from 2023 to 2030. So that would mean it reaches $310.4 million. So I guess it's growing a lot faster than we realize.
Yep.
They've got laser beam melting technology accounts for 42% of the country's 3D printed medical device market. So it seems like medical device is a very big one in Germany. Number 2 is the United Kingdom. That also kind of surprised me. Over 1/3 of surveyed UK professionals have adopted 3D printing technology, with 2/3 believing it will revolutionize their industry. And nearly 90% see 3D printing as highly beneficial for realizing new concept and design ideas.
Fascinating.
And then number 1, this is going to be shocking for everybody, is the United States.
Yay!
Woo! Get like bald eagles, like
So we
USA.
Bald
Okay,
eagle
I'm
carrying a
done.
3D printer.
we dominate the 3D printing market with
was
a
so
market value of $3.1 billion.
You heard?
That represents 22% of the worldwide market share. And it's predicted to strengthen further with projections indicating that the U.S. 3D printing market will reach an estimated, I'm not sure how this number translates. It says 33,782.4 million. So I think there's either a typo there or it's a very large number by 2032. And it's largely used across many sectors. The automotive segment dominated in 2023 with over 61% of the market share in the United States.
Yeah.
And in healthcare, it's used for artificial tissues, customized implants, and medical devices. And the aerospace and defense industries leverage 3D printing for complex parts and prototypes, while prototyping held a significant market position with over 54% of the market share in 2023. So it's a lot.
Yeah, it's a
Yeah.
lot. The list is very interesting because within the U.S., I've been thinking about regional expertise.
Mm-hmm.
So if you look at, besides San Francisco and the whole West Coast,
Mm-hmm.
if you look at who's doing interesting things with artificial intelligence, you could pick out like geographical areas that are, Boston, Pittsburgh. If you look at automation, like Pittsburgh
Mm-hmm.
is a big one, right? And I think there are countries, each country may have like a different expertise in terms of 3D printing.
Yeah.
Except for the U.S. because it's such a big market. So if you take
Right.
the U.S.
Mm-hmm.
out, where Italy one of the previous countries is looking at using clay. The other countries looking heavy in, or like Germany's doing stuff a lot in medical, right? And then automotive is kind of spliced in there a little bit, but again, back to the U.S. consumption market, it's so high. But I do think there's a lot of country specialization
Yeah.
that the article talks about.
I really like that the UK is coming in strong and second.
Sure.
That actually didn't surprise me too much. Having watched enough Top Gear, I know that like the UK automotive market and not just Top Gear, but like watching a lot of Jay Leno's Garage.
Sure.
The UK is amazing at making some of the most beautiful, intricate, high performance products. But only making like one or two of them.
Yeah.
Don't ask for them.
Yeah.
Don't ask them to mass produce anything. And
Right.
it's like 3D printing's perfect for them.
Yeah.
I mean, I think it also in the UK, a lot of the European countries, I think too, while a lot of companies are based there, there's a lot of universities overseas that are doing a ton of research into 3D printing
Right.
and revolutionizing it, especially when it comes to like medical and it comes to things that are very cutting edge. I think a lot of those universities overseas. I mean,
Absolutely.
they're doing it here in the United States too, but I think in some ways they have more funding to do it overseas than we do
Yeah.
here. So I think that's also, and they said, that research part is part of the weighted part of it. And I think that the UK definitely, like, they've got the university, Oxford University, I think that does a lot of research, things like that.
Well, like if you think about if you have the funding
Mm-hmm.
for manufacturing, but have no infrastructure,
Right.
3D printing closes that gap.
Yeah.
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 Yeah. We're seeing that quite a bit, the point of use of 3D printing, leveraging or adding to that benefit. But that was a great list, Elissa. Thank you. And I do really appreciate kind of the deep
That
dive
was
into each of the
cool.
countries.
Yeah.
Ramia, where can they find more info about us?
amtonline.org/resources. Like, share, subscribe.
Bing bong. Bye.
Bye.